Welcome back to our lessons on redox reactions. In this lesson, video lesson 2, I'm going to show you how to write a balanced net redox reaction without the use of the table of reduction potentials. The first set of examples would discuss redox reactions taking place in acidic medium. Now, the first thing that we need to do is we need to separate the oxidizing agent from the reducing agent. So first of all, we would use oxidation numbers to identify the reducing agent and the oxidizing agent. In this dichromate ion, oxygen has an oxidation number of -2. In the compound ion or radical, there are 7 oxygens, so that contributes to a negative charge of +14, of which 2 remains on the ion, so +12 will be needed to cancel 12 of the negatives. There are 2 chromium ions that contributes to the +12 charge. So in that case, the oxidation number of chromium is +6, 12 divided by 2. Hydrogen is +1, sulfur is -2. The dichromate changes into chromium, which has a charge of +3+, so oxidation number +3, and sulfur is on its own without being in an ion, so its oxidation number is 0. So the chromium's oxidation number decreased, which implies a gain of electrons, so this would form the reduction half reaction. The hydrogen sulfide, the sulfur's oxidation number increased from -2 to 0, which implies oxidation. So this would form the oxidation half reaction. It's a habit to start with the oxidation half reaction. So the oxidation half reaction starts with H2SO4. Sorry, I made a mistake. H2S. The H2S changes into sulfur. The reduction half reaction starts with a dichromate ion and changes into the chromium 3+ ion. Now there are some rules to be followed in order to continue with this method. First of all, we need to add waters to balance any oxygens. In the reduction half reaction, you've got 7 oxygens. It means that we need to add 7 waters. In order to get the 7 oxygens. The next thing we need to do is we need to add hydrogens in order to balance the hydrogen or add hydrogen ions. In the oxidation half reaction, I need to add 2 hydrogen ions in order to balance the hydrogens. In the reduction half reaction, we need to add 14 hydrogen ions in order to balance the hydrogens on the right-hand side of the arrow. The next step is to balance the rest of the elements. Now, in the oxidation half reaction, the elements are balanced. But in the reduction half reaction, I have not yet balanced the chromium. So we've got 2 chromiums on the left-hand side of the arrow. We need 2 chromiums on the right-hand side of the arrow. So now we're at a point where all the elements are balanced. The next thing is to add electrons to balance the charge. So the charge on the left-hand side of the oxidation half reaction is 0. The charge on the right-hand side of the oxidation half reaction is +2. So I need to make it 0 by adding 2 electrons. On the reduction half reaction, my total charge here is -2 plus 14. So that is an overall charge of +12. On this side, we have an overall charge of 2 times 3 plus, so it is +6. To go from a +12 to a +6 charge, I need to add 6 electrons on the left-hand side of the arrow. We're getting there. The next thing is to balance the electrons. Now, to balance the electrons, you've got 2 electrons given off during oxidation and 6 electrons taken in during reduction. So to balance the electrons, I need to multiply the oxidation half reaction. So in order to balance the electrons, we need to multiply the oxidation half reaction by 3. So 3 hydrogen sulfides will form 3 sulfurs and 6 hydrogen ions and donate 6 electrons. So now, with all the elements balanced, the charges balanced, the electrons balanced, we can write down the net redox reaction equation. So 3 hydrogen sulfides will react with a dichromate we get to hydrogens, 14 hydrogen ions on the left-hand side of the arrow and 6 hydrogen ions on the right-hand side of the arrow. So I can do a mathematical trick and we can cancel out the excess 6 and we'll have 8 hydrogen ions on the left-hand side. The electrons will cancel. Then to the right-hand side of the arrow, the products will be 3 sulfurs, 2 chromium 3+ ions, and 7 water molecules. I think I'll do the next in another video, so I'm going to stop this video here.